Good afternoon, everyone. My name is Anand, and on behalf of Godrej Material Handling, I welcome you to our next webinar from our storage and handling series titled Industrial Flooring Recommendations for Racking and Material Handling Equipment. Today marks the 10th webinar in the Storage and Handling Knowledge Series, an initiative which we started in May last year to bring our attendees learnings and experiences from more than Godrej's 50 plus years in the interlogistics space. The webinars have evolved over the months, where we have invited expert professionals to share their vast knowledge about the different topics important to the material handling industry. On that note, I come to today's webinar. In this webinar, we will aim to learn more about the different aspects of industrial flooring and their impact on the material handling operations in warehouses and shop floors. Today's webinar is being presented by our guest, Mr. Kaushal Parekh, who is the CEO and the founder of Impact Flooring India. He is a graduate in commerce and has done his master's in financial management and has specialization in ACI concrete flatworks and in design of concrete floors and pavements. He is also a certified floor surveyor under Face Consultants USA and has been in the industry for more than 22 years, initially offering solutions through products and since 2008 as a design build floor specialist. His company Impact Floors annually does more than around a million square meters of concrete flooring in India and surface treatment, and has now ventured into Africa. Before we move on with this event, I request everyone to please put their questions in the chat box on the right. We shall try to get to them in the webinar, or we'll reach out to you after the event in case you're not able to get to those questions. Please do remember to mention your name when you put the questions in the chat box. With that, I request Mr. Kaushal Parekh to take over, and I wish everybody has an insightful session.
Good afternoon, everybody. Am I audible?
Yes, you're audible, sir. You can please proceed.
Good afternoon, guests, patrons of the industry. This is a very important opportunity for given to us in this webinar series by Godrej, and we are very thankful to them to allow us to present the different aspects of floors, especially for material handling equipment and racking. So today's webinar is going to cover various floor considerations. We're looking at introduction of concrete floors, problems that are related in floors, related by warehouse developers, material handling equipment manufacturers, operators, negative impacts of poorly constructed or detailed floors, different types of construction of floors, warehouses, manufacturing facilities which are using these type of floors, floor construction techniques, advantages of floor types, floor finishes. So we're looking at various floors treatment services, guidelines which are currently available worldwide and in India for constructing floors, measuring them from floor flatness and levelness, types of material handling equipment which are used in warehousing and manufacturing facilities for handling materials, different handling material equipments and its sensitivity for use in concrete floors, and effects of floor finishes on material handling equipment. So floors, which have been one of the, I would say, bane of contention and one of the most important topics in industrial and manufacturing facilities. It's the heart of any facility. It's where all operations take place. It's commonly said that floors and roof are the main functions of a facility, an industrial type facility. You should have a roof which does not leak and a floor which allows performance of material movements and processes. Typical facilities that you can see, manufacturing, warehousing and retail. You have various problems in floors, right from delamination. Um, you have problems related with cracks, cold joints, uh, joint fillers which fail because of concrete shrinking over a period of time. The panels start to shrink and they open up the joints. Poorly detailed joints, floor flatness issues, joint intersections, bolts which come into play when you're looking at uh, old facilities which are now taken up by uh, um, new tenants coming into the floors. So some of the old rack layouts are continuously used. So those are basically left behind, and they create an issue in the floor. We're looking at floor delamination. These are issues which are related with, the surface hardeners which are used in the floors. These tend to debond from the mother slab. This is due to when you do an over troweling during the finishing process, or when you broadcast the floor hardeners on the surface and at an early stage, or at a delayed time. So they don't tend to basically bond between the mother slab and the surface hardener. This tends to create a problem, and they tend to create voids, which creates basically the air which comes out from the surface, from the surface below, because the surface becomes basically very hard, and the air tends to get trapped, due to which the hardener loses its bond when the air tends to come out. Typical damaged floor conditions when you're looking at joints, cracks which come into floors. Now these are also related with shrinkage in the concrete. This is typically the issue when you're looking at constructing the floor in open conditions. So the weather becomes a big issue. You have crosswinds blowing, and there's early drying of the surface, which does not allow the floor finisher to finish the surface in time. That leads to surface cracking. If you're looking at very hot and humid climates, that tends to aggravate the early drying of the floors, as well as when you're looking at poor quality of materials. Now, when you're looking at cement, if you use different types of cement in a particular floor, they tend to shrink variably. Sometimes, on a very rare case, batching plants break down and they take a long time in getting repaired. One of the projects that we actually had a issue about 5 years back in Mumbai, we were doing a warehouse project where the batching plant had a major fault and they could not repair it for 10 days. So we had to shift from the preferred vendor to an alternate vendor supplier, and that created problems in the floor related with color changes in color, shrinkage cracks which did come into play, which were then addressed through changes in the raw material source. So these do come into play. You have patches during the life of the floor. As you utilize the surface, there is naturally the surface which wears off over a period of time, and you surface tends to peel off. You have objects falling onto the surface which create dents, and that creates issues of maintenance. You have cold joints. So again, another issue of where the concrete supply had a break, due to which there is delay in the supply, and this creates cold joint, or even at times the flooring equipment breaks down. So you're not able to pour the concrete in a stipulated timeline. That creates cold joints in the floor. Abrasion resistance, which are required. So you're looking at if you're looking at purely specified surfaces that tend to wear off due to excessive material movement. So when you're looking at e-commerce companies or 3PL companies which have heavy material movements, you have a lot of abrasion coming on the surface, coming through the surface. And if you don't use good surface hardeners, these tend to the top skin tends to wear off. When you're looking at floors in curling stresses, this is of course again another challenge that are faced, due to which you have um, accidents do happening at times when the concrete tends to warp and curl. The racking the racking posts do tend to have issues coming in. You need to create you need to use shims below the post legs to keep it in place. And of course the bolts and racks, bolts of the racks which come into question, especially in an existing facility which are changing over tenants. So you need to remove these bolts which do have an issue in the floor usage, as well as in material handling equipment movements. You have floor intersection cracks coming in, and even at times issues related with isolation joints. So you'll have problems related with angular cracks coming in at column intersections, wall intersections, re-entrant corners. These would be issues which, although basically are aesthetic in nature, do have a functional issue, because if the columns as the building ages, you see a typical settlement which does take place, which is a natural settlement, and that creates pressure on the floor. So if the columns are connected with the floor, you will see angular cracks which do come into play, typically at 30 to 45-degree angles. So you need to isolate these joints. Typically, another issues which we do come across is preformed joints. Certain manufacturing facilities use steel lugs along with typical C sections and I sections, which tend to break off over a period of time because of poor levels. Or armored joints, which are poorly fixed or poorly manufactured. They create a restraint in the floor, and that creates issues related with the top area breaking off near the joints, especially where the shear studs or the load transfer dowels are existing. These related to material handling equipments not performing to its optimum levels. You see its bearings tend to break off. You have tires which have problems coming into play. So these joints, as the wheels tend to move forward, the joints tend to open up and the wheels keep hitting these particular locations where you see that there's a shock which is created, and you see that these joints tend to fall off, and the mouth keeps opening up. So when you're looking at loadings, it's not correct to use loads of racks near joints. Typically, you should use in typical socket joints away from the particular joints. You're looking at least 300 millimeters away from the joint, so that there is no basically the loads which are directly transferred onto the joint. If you're forced to use a joint, if you're forced to use a rack post load near the joint, it should be armored joints. These have a tendency to and an ability to transfer the loads in a much better manner as compared with SON-induced joints. So speculative warehouses, the major challenges that companies do face, especially in flooring companies, are issues related with where the rack legs would end up being. So the main advantages would be to design a floor with minimal joints or all major construction joints using armored joints, so that there is even transfer of load when there is load exerted either from a point load from a racking condition or from a vehicle load from a material handling equipment movement condition. When looking at different types of floors for manufacturing and warehousing facilities, you have floors on ground, which are typically called as slab on ground. Ground supported slabs are some of the nomenclatures which are used. Floors on pile supported slabs, so where the ground conditions are very poor, you look at casting the floors using a finite element analysis to ensure that the design is done as per the load requirements. You have composite decks where you're looking at mezzanine levels in steel decks in pre-engineered building structures, and where you would use it as a office building, office facility. I'm sorry. You're looking at certain packing areas. So e-commerce facilities use those locations for packing of light good materials at times. Even manufacturing facilities, if you're looking at packaging industries and similar type of industries, they use those elevated structures for not just the office and commercial applications, but also for their packing and small lightweight production. You may see this in electronic industries as well. Floors on elevated concrete slabs. So when you're looking at multi-level production, typically in textile units, again packaging industries, lightweight electronic industries, even certain engineering industries. And you have post-tension floor slabs as well. What are the construction methods which are used typically? So you're looking at conventional vacuum dewatered floors, which is generic name now called as Trimix, the way we have Colgate for toothpaste and Xerox for photocopies. Same way, Trimix has become a generic name for vacuum dewatered floors. These are systems which we will explain in the forthcoming slides. Along with that, we have options such as truss-screed, where we are looking at laying the floors using a truss-guided equipment. Another equipment which is a power screed, which is a handle element. And now the most fast-growing element in construction, especially in warehousing industry, is the laser screed. These equipments help in casting floors in wider panels, along with using larger panels so that you can cover bigger areas in floors. And then finally, constructing floors for VNA applications, for flat floor techniques, for VNA floors or very narrow applications. When you're looking at VDF methods, you are looking at beam screeds, typically 4 meter wide. So you're looking at setting up your formwork at every 4 meter locations, and maybe casting almost up to 40-50 meters in length. So typically you're looking between 200 to 300 square meters of casting areas. And you use a beam screed vibrator to compact the concrete and screed it. Thereafter, you do the basic tooling and then put suction mats to suction the so-called excess water from the concrete, and finally use a hardener if specified, and use a floater to power floater to finish the floor. Typically in VDF, the concept is to go with a highly workable concrete using at times additional water, and then try to suction it out using the suction techniques. Truss screed has been around for almost 2.5 decades in our country, and probably close to 4 decades worldwide. Now, of course, in the world, if you see, this technology is not widely done. This is prima facie done in only now in defined movement areas in VNA applications. But you're looking at, again, spans which can be from 4 meters to as wide as even 12 meters. Practically, from a flow construction, you could restrict yourself to about 8 meters. Hence, you're reducing the construction joints, and of course, you're also trying to increase your output for the same amount of workforce, or maybe slightly higher workforce, to do a higher volume of work. This method of floor construction does offer good amount of flatness in the floor construction. You can control the flatness with better tooling because you're not having such wide widths. You typically between 6 and 8 meters, which are manageable to control the tooling in the floors, and you do get better numbers in floor flatness and levelness. Power screeds are generally used in elevated decks along with laser screeds. In India, most of the steel decks which are being designed are not composite steel decks, are only simply supported decks. So at times, using a laser screed or higher end finishing equipment becomes a challenge. In such a scenario, you need to use power screeds, which help in which are lightweight screeds, which help in casting the floors and basically doing areas up to 300 to 400 square meters. The most widely accepted norm worldwide, and now which is also fast gaining acceptance in our country, is the laser guided screeds. These are laser controlled equipments. If you can see, these are with remote control techniques, or manually operated techniques, or driven techniques, so that the screeds can be powered, and you can easily cast large areas. So at one pass, you could do 20 to 30 square meters. There are now new screeds available which can do even up to 60 square meters per pass in a day. So you're looking at increasing your outputs from what you were between 300 to 200 to 300 square meters in VDF technology. You are upgrading down to 400 to 500 square meters in truss screed finishing systems. And now with laser screeds, you can go from as low as 600 square meters to as high as even 3,000 square meters. Practically in our country, 1,500 to 1,800 square meters have been easily achievable by flooring companies, where the where the RMC or the ready mix concrete is available with large production support. You could extend that to even beyond 2,000 to 2,500 square meters. The world record was done about 2 years back in the US, where a single floor was casted over 250,000 square feet. It's close to 23,000 square meters in 38 hours using laser screeds. Of course, they had to use about 4 laser screeds to complete the total area, but you could achieve that sort of volume if there is a proper coordination. So that was a benchmark now set in North America for the world to follow. When you're looking at flat flow construction techniques, you're looking at typically small aisles. So you're looking at between 4 and 5 meter wide panels, and this is using conventional saw beams to control the levels of the floor, and precise tooling along with precise quality control equipments and quality control of the concrete itself to ensure that you get a flat and level surface. These are very stringent norms that needs to be constructed with and to be followed with during the construction process. And floors are typically measured within 24 to 72 hours using typical profilograph equipments, robots, to ensure that to see whether you've achieved the flow numbers. All right. When looking at floor construction sequence, typically you're looking at the floor design. So you get inputs from clients when looking at rack loads, machine foundations. If you're a manufacturing facility, so you need to know where the machine foundations are, what type of loads either these foundations, are they going to be isolated, or are they going to be connected? Machines itself, are they going to be rested on the floor, or are they going to have separate pedestals for them on which they would be put, so that the vibratory loads are transmitted um, to the subbase or within the floor itself. So you need to design the floor accordingly. When you're looking at warehouse, you're looking at surface conditions. When you're looking at rack conditions from load perspective, you're looking at point loads from racks. You're looking at line loads from mezzanine conditions, and as well as your movement from material handling equipment, based on which typical floor design is done. So you could look at this particular schematic where you have the blue lines, which are the construction joints, and the pink lines, which are the control joints in the floor. But for all of this to happen, you need to have a good subbase. A properly designed subbase will ensure that the floor will be taking its load in the right way. A poorly designed subbase, a poorly prepared subbase, will have issues related to rutting, related to settlement of the surface, and due to which again you're looking at the panels sinking, and you have problems related with maintenance coming into picture. You have structural failures from the floor slab coming into play, with settlement issues coming in. So when you're looking at constructing the floor, you need to use a good vapor barrier to separate the subbase, whether it's a mud slab or a dry lean concrete or a wet mix muram to your reinforced concrete surface. So you use either an HDP, a high density polyethylene membrane, or an LDPE membrane, depending on the specification and the location where you're doing the floor. After which, typically these days we use armored joints in floors. You're looking at preform construction joints. These behave like expansion joints and construction joints all rolled into one. You have various dimensions, so you have linear joints, and you have sinusoidal shapes. You have disruptive faces, which help you in even better load transfer between panels. You need to isolate your columns and walls with isolation pads, re-entering corners using or dock levelers using rebar around it, so that you do not have angular cracking coming in. In dock levelers, you have an angle on top, so that you do not have the floor getting damaged. Also, when the materials are moved with the metal line equipment along, and also your truck when it comes in near the loading platform or your dock leveler. You generally install a laser level to control the floor levels and to basically, of course, guide the laser screed equipment. You would use fiber reinforcement, which are typically steel or synthetic fibers. These are three-dimensional reinforcement elements to help control the plastic shrinkage cracking, along with improving the fatigue resistance and impact resistance in the floor. Or you could use rebar, which is a conventional approach in floors, or even where the proper where you know that the soil conditions are poor, or when you know that the load conditions are higher, you could use a combination slab. So you use a combination of steel rebar along with fiber reinforcement to get the best of both worlds. Once the batching is done, we control. We need to check basically the slump at the batching plant to ensure that it is as per the original design mix of the floor specification that was laid out from the flooring contractor's perspective, because you need to have the concrete to be workable, and if the concrete is coming from a very long distance, say if the plant is about an hour's away, so you need to ensure that the slump of the concrete is at a higher level, and once it reaches the site, it is compatible with the equipment or the technique that you're laying the floor with. So once the transit mixer reaches the site, you again check the slump to see the suitability of the concrete. If it's not in tolerance, then you need to reject the truck. If or you should have a good quality control manager from the RMC supplier as well to ensure that it's modified. If it's just out of specification from, let's say if you're looking at a tolerance of 130 to 140, and if it comes down to say maybe 120. So if you want it to come back to 130, a slight dose of admixture is managed at site, but typically we should look at each truck going with exact specification. Site management does have its own challenges coming into play, and only a proper quality control manager can control it. So you need to have a good quality control system in place. So with the advantage of fiber only floors, you can have a direct discharge of the concrete, or if you're using rebar, you need to use concrete pumps, so you can be pumped into the panels. Once it's placed, you have basically you just need to level the surface, and with a laser screed, either you can use a laser screed or a truss screed to level and screed the strike of the concrete initially, level the floors. Once it's done, you have basically the initial control of the levels that are checked. You use typical vibrators, needle vibrators to compact the edge areas or corner areas where the equipment cannot reach. And you have manual finishing techniques to at corners where equipments are unable to finish the floor. So once the concrete is laid, you use the typical tools to finish the initial levels. I've lost the connection. Sorry, I think we lost the connection there.
You're back now.
Yeah. So trying to get. Yeah, sorry. No, I'm good. Thank you. So sorry for the delay. There was a connection issue. So once the screeding and the tooling is done, you need to use typical bump cutters to ensure that the surface high spots are removed, or if there are low spots, you can fill with the concrete when it's still green in nature. Once the concrete has reached its initial set, you can broadcast your floor hardeners using manual dispensers or automatic dispensing elements. Once the floor hardener is broadcasted, you again check your levels once it's set to see what is the floor levels you've achieved, and wherever again the retooling needs to happen, you need to take care of the same, so you can remove all the excess levels. Once the tooling is completed, you start finishing the floor using power floaters and ride-on trowels, and you use basically a good housekeeping system to ensure that all the pop-outs, basically your aggregates which are coming out, or if you're using fiber reinforcement, if the fibers are protruding on the surface, to remove them manually once before the final set of the concrete. You have a team managing your edges so that you get an even finish near the edge, and also a neat finish. Once this final finishes is done, you do the final pass using the ride-on trowels using blades, and the floor is finished. Once that's done, you use curing. So either you would use a curing compound or you use water curing and use it with hydration for the number of days. So if you're using a curing compound, you would typically cure it for about 7 to 8 days minimum. And if you're doing water curing, you do it for at least between 10 to 12 days at least, ideally up to 2 weeks. Once that's done, at the same time, you start cutting your joints. If it's a saw cut floor, so you typically need to cut the joints in 24 to 48 hours. On the highest side, 72 hours. But no, the norm would be between 24 and 48 hours after the placement of concrete. Once the curing is completed, yeah, and the floor is, if there are no surface treatments you're doing, you come and fill the joints with specified joint fillers. Earlier, people would specify polysulfide sealants. That is now moving out of specification because it's a very soft material, and you need to use at least a semi-rigid product with a good moment accommodation factor, so that the initial months of the floor it can take the movement of the shrinkage of the panel once the concrete is shrinking. So you're looking at polyurethane joint fillers in the initial life, or you need to upgrade to semi-rigid epoxy joint fillers or polyurea joint fillers. In India, this trend is now that to specify basically the polyurethane joint fillers, and thereafter, once the initial shrinkage of the concrete is done, you specify the refilling of these construction joints. Excuse me, using removing the existing joint fillers and replacing them with a semi-rigid epoxy or a polyurea joint filler. This is a typical finished floor. This is a surface treated with a densification element. So what are the typical advantages and the type of floor types of construction? So you have saw cut conventional floors, where you cut the floors after within 24 to 48 hours. Then you have joints which you support with using dowels, either round dowels or plate dowels. The other technology that we are looking and are seeing increasingly being accepted, especially in warehousing condition or even in factories which do not want repeated issues of construction joints failing, is using armored joints at all construction joint locations. These help in eliminating the maintenance costs of the construction joints breaking up due to the movement of material handling equipments. The next in line is, of course, the jointless floors, which is most widely used system in the European Union and also fast gaining popularity in our country as well. A couple of the e-commerce companies in our country have now moved completely towards asking when they build their own warehouses or when they get a warehouse as a build to suit application, from a developer, they use a jointless floor as a solution. In this situation, you're looking at complete elimination of these joints, all the control joints, and construction joints are used with armor joints. The next level of specification now, which is also gaining ground, is seamless floors, where you remove all types of joints in the floor and you design the floor using maximum crack width ratio and using a combination of high tensile steel fibers and rebar. And finally, the V-inner flat floors. This is an animation of a jointless floor slab. So you're looking at typical buildings. You could do large panels. In India, if you're looking at a 20,000 square meter facility, you could easily do this in about 16 pours, considering the current availability of concrete. So all you see is just a few lines of armored joints, which will be visible on surface, as compared with a traditional floor slab, where you have multiple linear armored joints, socket joints coming into play. So you're looking at if you're looking at 20. You're looking at reducing the control and construction joints by almost 80 to 85%, as compared with when you're looking at jointless flow technology. When you're looking at jointless floor slabs, the movement of material handling equipment as well as the loading from racks are very flexible. You can see a smooth movement of material handling equipment between panels, from intra-panels to inter-panels coming into play. You can easily load the floors unilaterally across the length and width of the floor slab. All your joints are reinforced with armored joints, which are structural load-carrying elements. As compared with that, when you're looking at traditional floor slabs, as you move in line, of course, this is more of an exaggerated view element, but you can see that the forklifts or the material handling equipments do experience a lot of jerks, a lot of bumps due to the potholes coming into play, the joints breaking up. These are issues which you face over in conventionally casted floors as compared with jointless floors. So when you're looking at traditional floors, you're looking at basically these type of joints which tend to open up and create maintenance issues coming to play, as compared with a seamless floor as a jointless floor, which the operations are much more seamless in nature. When you're looking at a jointless technology, you're looking at improving your warehousing speed, your movement of your material handling equipment, so your throughput improves, and that naturally helps in the overall value for the logistics companies and the 3PL companies, which are needing to ensure that their materials move quickly within the facility and in and out of the facility as well. When looking at epoxy, when you're looking at floor finishes, we have epoxy finishes, polyurethane finishes, MMA finishes, floor densification, and polished concrete. So epoxy has been around for many decades. These are floor coverings. You have under floor coverings your epoxy PU, polyurethane, and methyl methacrylate MMA. These epoxy finishes range from a painting system, which can be a few hundred microns, to thicknesses which range up to 3 millimeters in thickness, and typically used in floors for aesthetic finishes, or if a client wants to have color coding from different processes coming into play, or also as a seamless finish. The polyurethane finish is an upgraded technology from epoxy. These are not as moisture sensitive as what the epoxy coatings are. These are much more robust in nature. The thicknesses range from as low as 3 to 4 millimeters to even as high as even 8 to 10 millimeters, depending on the system and depending on the application of the clients. The next in line is the methyl methacrylate, which is another form of floor finish, floor covering, which are now gaining, at least in the gaining popularity in the European Union. You have floor densification where the surface is kept naked. The floor is not having any floor covering, but you're treating the surface with the chemical densifiers. You have typically sodium silicates, lithium silicates, potassium silicates, which help in surface densifying the surface by penetrating into the pores of the concrete. You need to slightly grind the surface and allow the chemical to penetrate. These penetration depths range between 3 to 5 up to 7 millimeters, depending on the type of densifiers you end up using. These are topical application techniques. These are basically to ensure that your surface is dust-proof, sealed and hardened. It improves your surface wearness by 30 to 40% as compared with conventional concrete. The next level of surface treatment is polished floors, which where the densification process becomes a part of this system, and where you mechanically grind the surface up to from as low as between 500 microns to 1 millimeter to as high as 7 to 8 millimeters, even up to 10 millimeters in poor floor conditions. In existing floors which are needing repairs, you could rejuvenate them using polished concrete techniques. In new floors, you can improve the surface aesthetics by giving various options like a cream finish, a salt and pepper finish, or an exposed aggregate finish, depending on the type of the floor which is going to be used. So if you're looking at a retail, a commercial retail, I would say like a restaurant or in an office space, you could grind to an exposed aggregate finish. Or if you're looking at retail, you're looking at maybe a salt and pepper finish or a cream finish. Typically in industries, in new floors, you're looking at cream finishes and salt and pepper finishes. So the various guidelines which are available worldwide are basically the Concrete Society Technical Report number 34 from the UK, which is also called as TIA 34, which give the specifications of the design of the floor slabs and the various movement criteria, the floor flatness criteria from free movement areas and defined movement areas. You have the DIN standard from Germany, which is now superseded with VDMA, which is the latest technology and latest measurement survey system from the European Union. The ASTM standards, which is the F number system from the US. And now in India, we have a guideline called the ICI TC09, which is developed by the Indian Concrete Institute, along with the flooring stakeholders and designers, along with various other clients who have contributed in making this guideline. This is just a snapshot of each particular guidelines. You have the TR 34 and the ACI guideline. You have the VDMA and the ICI guideline. So what are the type of floors? When you're looking at, when you construct a floor and you see it's level, but it's not flat. It's flat, but it's not level. These are typical issues that you come across from material handling equipment users and racking vendors. You can see that it's from a level surface. If they do not have, the racking vendors do have an issue coming into play with extra shims. We are looking at floor specifications. This is a snapshot from the British standard, from the 8204, from the surface regularity applications, especially used in uh, elevated decks, and the free movement specifications and defined movement specifications as per the TR34. You need your flatness and levelness requirements, especially when you're looking at high reach, high bay warehousings. So you're looking at racking conditions in excess of 10 meters, going up to 14 meters, 15 meters. So you need uh, uh, racks which are going to need a complete sturdiness, along with the material handling equipment. So you're looking at your reach trucks, your pickup trucks, which will have sophisticated electronic assemblies, which will ensure that there is no sway. And if your floors are not flat enough, you will see that as the man-up truck goes up to pick up materials or to leave pallets, the equipment tends to tilt, and there is an issue of safety coming to play when you're looking at the material handling equipment, the MHE moving. It may bang into the racks that may lead to disasters, and you may see collapse. Well, this is more of an exaggerated rule, but you're looking at accidents which are waiting to happen. And in today's day and age, health and safety of the operators, of the overall environment is of paramount importance. So a good flat and level surface is always important from a healthy movement and a healthy operation. When looking at various types of equipment, these are typical examples. You're looking at a stacker. These stackers are generally used in smaller heights when you're looking at heights up to 8 to 10 meters, 6 to 8 meters of racks. That's where you use a stacker for ease of picking up the materials. And the next in line is basically a higher reach truck, which allows you to use the material to be picked up to 10 to 12 meters. When you're looking at the next level is basically the VNA trucks, where you're looking at very narrow aisle applications, typically aisles which are 1.7 to 1.5 meters in 1.8 meters in width, and you have basically a turret stock picker or an articulated truck which has an ability to move its head and pick up materials without actually moving, without actually changing directions. The reach trucks that you see here is used in heights, again, as mentioned earlier, up to 10 to 12 meters or even up to 14 meters in height, to retrieve materials or to put materials. So if you look at flow coverings, especially epoxy flow coverings, they have a direct effect on material handling equipments. When you're looking at the wheels coming into play, when you're looking at the epoxies, the covering tends to tend to come out. These elements get stuck into the wheels, at times get trapped into the electronics of the machines, and they tend to break down. So these have an issue of increasing the maintenance cost of all the material handling equipments. You have blistering coming through the outgassing of the vapor barriers which are entrapped. So these tend to create problems in floors, and again, once they tend to chip off, the material handling equipment do have problems in, again, movement in the floors. These are issues which are currently faced by clients. So the solution to these are you're looking at polished concrete, you're looking at floors which are now moving away from floor coverings and going into surface treatments, keeping the floor polished and shiny. These are the current specifications which the clients are moving towards to make the surface more durable for use in the floors, for use in their operations. With that, I conclude this presentation. Thank you for your time.
Thank you, sir. That was indeed a very insightful and a knowledge-packed presentation. So, sir, we have received a couple of questions from our attendees.
Yes.
Yeah. So I'll just start off with the first question. So could you elaborate on the pricing differences which exist between the five type of floorings from saw cut to VNA super flat?
So, well, it depends again on the load criteria. So, if you're looking at a, I would say from a load, let's say we standardize each element as a 150 mm or 6-inch concrete. We keep as an M30 grade as a standard specification. So if we try and keep that into place, or let's keep the thickness at 200 millimeters, that would be more rational when you're looking at maybe floor loads being increased. These days, when you're looking at 12-meter racks, 14-meter racks, your design criteria goes up to even 200 to 225 millimeters in sections. So, but typically talking, let's say we have a 200 millimeter thickness. You can in a saw cut floor or a wide armored floor, saw cut floor would typically cost you between 170 to 180 rupees a square foot minimum. It could go up to 200 rupees a square foot as well, depend on material costs from region to region. When you're looking at a wide armored cost, where you're removing the construction joints by using only the armored joints in those locations, you're looking at an average cost going up to about 10 to 15 rupees a square foot, or the about 200 rupees a square foot that the client would end up paying. The advantages in a jointless floor would be you could redesign this floor for the given load by reducing the section by almost about 20 to 30 millimeters, with the design principles being a little different from, or the approach being a little different, if I may correct myself. So if we are to keep the same sections of 200 millimeters, the cost would increase by about 15 to 20% as compared with the conventional concrete. But if you are looking at redesigning the floor to reduce the sections, you'd probably do the same at the same cost. You would get a jointless floor, which has been our findings over the last few years that we've been promoting jointless floors in our country. You're looking at times savings even up to 10% as compared with conventional construction techniques. A super flat floor or a VNA floor construction and a seamless floor construction are higher in cost. You're looking at somewhere in the region of around between 250 to 300 rupees a square foot at least to construct a VNA type of a floor or a seamless type of a floor. But the advantages in a seamless floor is far more. You have a floor without joints, so you do not have any type of armored joints, a sawn induced joint anywhere in the floor, and it's completely maintenance free. So both jointless and seamless are maintenance free floor approaches. In a VNA floor, these are specific requirements from a client's perspective, who you see a lot more right now only in a manufacturing facility which is having a shortage of space, but they are looking at increasing their pallet positions by reducing the aisle widths. So you're looking at basically increasing the thickness of the concrete by having higher heights of your racks. So you're looking at between, as I mentioned, if I standardize the sections between 200 to 250 millimeters from the applications, you're looking at a cost structure ranging between 200 rupees to almost 300 rupees a square foot.
Got it, sir. Uh, so could you also shed some light on the certification of floor levels and flatness which is done in India and the uh, organizations which do that, which help with the certification?
I'm sorry, I could not hear you properly. Could you repeat that, please?
So, how are certification of flow levels and flatness done in India, and by whom?
All right. The floor certifications and survey are done by third-party survey companies. You have quite a few of them now available in the country. Uh, Internationally, if you look at the main companies who have been doing this work are phase consultants from the US, phase consultants from the UK, Monofloor from again from UK, and you have Flat Floor Consulting again from the UK. In India, we have Monofloor who have an operations here. We have we have concrete planners from who are based on in Delhi. We have Flow Logics Consulting and Testing Services, which is our organization. We have recently started a flow survey and testing company, which is now called Flow Logics Consulting and Testing Services, based out of Mumbai. We have Emerging Materials and Technology Services from Chennai, and yeah, I mean, these are some of the companies who do floor surveys. Now, the floor survey techniques typically use either floor profilers, you have equipments like dipstick, you have D-meters, your axiom type of equipments, which are flow profilers, which survey the flow for you. There are techniques for free movement areas and defined movement areas, which a flow surveyor adapts and implements depending on the application. Anand?
Yes, sir. I understand. So the next question is about, so does the quality of the wheel material or the material construction of the wheel of an MHE, does it impact the flooring in any way?
Yes, it's a very good question. Yes, they do impact the floor in some way, in a large way. So, well, I'll give an example of one of our own projects which we executed in South India for a third-party logistics company. They were typically into they had two divisions. One was a supply chain division, which was into managing like a third-party logistics, and then they had an express logistics service where they would gather materials from various locations in the day, and in the following either in the night or the following morning they would dispatch to its respective destination. So they would come for only a few hours in the facilities. They would not be racked, they would only be stacked on the surface. The pallets would be kept on the surface, the goods would be like the cartons would be just kept on the surface, and a BOPT truck, pallet truck would be using. So typically in these type of applications, we've seen people use steel wheels in their pallet trucks. Now these damage the floor in a huge way. The joints break up, the surface erodes very quickly. We've seen that happen in one of our facilities, and the client had to had initially there was, let's say, an misunderstanding, and after nearly close to about 6 to 8 months, we had to make them understand, and they had to pay for doing surface treatments, redo the surface areas, patch up the already damaged floor, and they had to replace those steel wheel tires with polyurethane coated wheels. So what I was trying to drive here is steel wheel trials. The tires are very damaging on the surface. You're looking at nylon wheels or polyurethane coated wheels, which are much more softer and do not create that sort of friction on the surface as compared with the steel wheels.
Got it, sir. So the next question is, how does one go to address the floor sinking issue?
Well, that has to be investigated through a proper. If there is a floor sinking issue, you need to at times open up. You need to core cuts, or it has to be properly investigated through a third-party investigation company. There are aspects related with, as I mentioned, core cuts. You may have to maybe at times cut a panel and see if there is any sinking of the slab. There was an issue a couple of years back in Mumbai in one of the facilities where the developer had ignored the presence of a pond in his facility at the time of development. And as you know, in Mumbai and its surrounding regions, it rains quite heavily. So the pond overflowed, and it sort of washed away the base. That led to a lot of issues where the floor sank. The flooring contractor was unfortunately stuck for a long duration, and through a third-party investigator, they were relieved uh, with the investigation, which showed that the pond had actually overflowed and the water had gushed in, and they washed away the entire sub-base preparation, and and the developer had to rebuild the floor literally, and their handover period was delayed by almost a year. So these are aspects which do come into play. So you need to be very careful. Another instance which we come into we've seen some of the developers at times use a drainage system, a wide drainage system near the base, and if you do not have a good waterproofing system, the water tends to find its path through the subbase, and that tends to again have issues coming into play. So if these are issues related to water coming as playing as a truant as a in the floor surface. Now also, if you're looking at poorly prepared surface, if you do not give the right time to prepare the subbase, well, the investigation method would be, as I mentioned, to at times do the core cuts and investigate where the pockets have created, and basically at times use polyurethane foams to lift the panels and repair the panels, or cut those particular areas, recompact the subbase in those particular locations, and then recast the floor in that given zone. That's an expensive affair. Anand?
Yes, sir. Uh, so the next question, yeah, the next question, sir, is on epoxy flooring. So is epoxy flooring a right solution for addressing flooring cracks in places requiring MHE movement?
No, I would beg to differ on that. Epoxy flooring is not the solution for cracks. You have crack filling elements which can fill those cracks. Now you may have a problem related with floor levels at times, where again the client wishes to have a seamless movement. Now, if you're looking at that as an option, people have used epoxy floors, epoxy coverings as final floor finishes. More often than not, people are using this from an aesthetic perspective, from the dust proofing, from ensuring that if they are an engineering facility, then the oil droppings which do come on the surface, that is controlled and they do not directly penetrate into the floor surface. If you're having manufacturing processes, you want to have colors, so various color codings coming into play. So you for your gangway areas, your walkway areas, to your actual production areas. But using epoxy just to cover the cracks, it's not the best solution. You could use a crack filling material, and you could basically use a good polished floor system to ensure that the surface is smooth and dust proof.
Understood, sir. Uh, the next question is about the basically the wire laying. So, could you please explain how the wire laying is done for wire guided MHE?
So you need to first cut the grooves and to the desired depth as specified by the manufacturing by the VNA truck manufacturer. Thereafter, you would have your magnets, your transponders, which would be embedded in those in the gaps in the control in the socket SON-induced joints. Then you use basically the wires, they are connected, and you basically use the joint fillers, the polyurethane joint fillers or a semi-rigid epoxy joint filler to fill the seat, to fill the uh, fill the joint. It's basically from a wire laying perspective. I would you got to take the guidelines of the VNA truck manufacturer. They would help us in as a floor laying installer or specialist flooring company in VNA trucks, VNA floors. I beg your pardon. Sorry. They would need the guidance. They would have a specification in place, and how to install the floor, how to install basically the wires. That is, there is a manual given by the VNA truck manufacturers. You have to follow those specifications.
Understood, sir. Uh, could you please elaborate more on the simple techniques which can be used to ascertain suitability of a floor for an MHE?
Sorry?
So, for a material handling equipment, how can one ascertain the suitability of the flooring?
Right. So if the processes of the facility owner is having a clarity from, let's say they have a lot of, let's say it's a warehouse, then we would definitely encourage the client to think towards looking at a jointless floor as a solution, because if you're looking at a SON-induced floor, you are, or just conventionally constructed floor, you would have problems related to construction joints breaking up. So the bare minimum specification would be to use an armored joint in all the construction joints. If the consultant is not willing to look at a jointless floor, or if the client is not willing to look at a jointless floor from an initial cost perspective, then you could use their armored joints around all the construction joints, and that's the way forward today, because you do not want your joints to break up during the material handling equipment movements during the operational phase of its facility. Also, when you're looking at when you do not want any interruptions from maintenance perspective coming into play, then jointless floors or seamless floors are the way forward. Conventional floors, sorry, I just wanted to add one more point, is that conventional floors are good when you know that you have too many machine foundations coming into play from a manufacturing perspective. So you have too many trenches. Let's say if you're in a textile industry, you have ducts, you have trenches coming in for dehumidification of the yarn. which it produces, so which the facility produces. So you're looking at in those locations, or you're looking at engineering facilities, like then in those locations you're looking at a son-induced floor, because you have too many penetrations coming in the floor. Jointless floor is not the best option in those conditions.
Understood, sir. Uh, so could you let us tell us if there are any different flooring considerations based on different seismic zones?
Sorry, I lost you in connection.
Uh,
What did you
yeah.
say?
So are there different flooring considerations for for different seismic zones?
Yes, well, the design criteria changes from seismic condition locations. Typically, you're looking, I mean, when you're looking at a warehouse racking condition, so if you're looking at the seismic zone 4, you may have to specially anchor the racks. So in an eventuality where there is an earthquake and a strong earthquake coming into picture, you have anchors and you have stabilizers to ensure that the racks remain in place and they do not buckle during the lateral forces which it will experience during the earthquake uh, when the phenomenon occurs. When you're looking at uh, other designs, again, you're looking at probably increasing the thicknesses of the concrete to accommodate the lateral forces in the concrete, in the floors that it experiences. So when you're looking at, let's say, a regular design floor, which may be 150 millimeters in thickness, you may have to end up doing maybe 180 or 200 millimeters with extra reinforcement to accommodate these lateral forces. So the design criteria does differ from region to region, from seismic zone region to region. Anand?
So that was very interesting to know. So if you had to give an estimate, could you tell us what would be the typical life for an industrial flooring?
Typical life for an industrial floor would be, well, actually, floor companies these days are giving warranties which are between 5 and 10 years of the service life of the floor. That's just the warranty part I'm talking about. When you're looking at serviceability, people are looking at 25-30 years minimum from a floor design perspective, and that's possible with only seamless floors and jointless floors. uh, you're not so much in the sawn induced conventional construction techniques, because that does tend to have repair. Does demand repair over a period of time. Jointless floors and seamless floors do have that advantage over conventional design floors, and you could enhance the life by at least 1.5 times to 2 times as compared with conventional concrete design floors.
Okay, so this is the final question which we have from our audiences right now. Um,
Yeah.
yeah. So the question is basically, so for warehouses which are on lease, so a lot of warehouses these days are leased out. So what would be the best way to repair cracks?
Well, the best way to repair cracks would be, to use crack filling elements. Now, that depends on the type of cracks which are there. So many times we've come across clients who see surface crazing, which are, shrinkage of the surface hardeners, which are really uh, more of an aesthetic in nature rather than a functional element. So these need not be touched actually. Only those type of cracks which are wider in nature, more than 0.5 of a millimeter, would need to be treated. Less than 0.3 of a millimeter crack width would could be ignored at this point in time. But higher than that, you need to use a crack filler. You need to also know if there's an active crack. So if there is a settlement issue, so the crack may widen over a period of time. So you need to actually observe it for maybe 3 to 6 months horizon, and once the crack becomes dormant, that's when you treat the crack and heal it with a crack filler. A good semi-rigid epoxy joint filler can be used it can be modified using certain techniques to use it as a epoxy crack filler, and that works very well. There are ways to finish the surface, to grind off and ensure that the levels are matched. These days, we also have color-coded epoxy joint fillers and polyurethane joint fillers, which can be modified as crack fillers and can be matched with the color of the concrete. And you would not be able to identify what would be where the crack was actually. Anand.
Yes, sir. So in the meanwhile, we've got one more question. Another question on seismic zone. I'll be asking the question: the impact do we have on the industrial floor due to seismic and non-seismic rated anchor bolts from the racking system?
Can you repeat the question, please? Again, we lost
Yeah,
you there.
sorry, sir. So, how much impact do we have on the industrial flooring due to seismic and non-seismic rated anchor bolts from the racking system?
Ah, sorry, but I do not have much knowledge on that part. I will, if we can make a note of this, and if the if the um, um, if we can get an email from the client, we can find out the right information and come back to you on this. At this point in time, I do not have this information.
That's all right, sir. So those are the questions for today. Thank you so much for taking out your time from a busy schedule and like being here with us for the webinar on industrial flooring accommodations for racking and MSU. Thank you so much.
Thank you very much for this opportunity by Godrej Group and Godrej Material Handling Division for getting us to offer basically an insight on concrete floors. Thank you. Have a good day.
Thank you, sir.